Welcome to the Process and Personal Safety Lecture for CHE 460. Now more than ever, safety culture is critical. Safety culture is policies and attitudes that reinforce safety as a core value of companies and organizations, and you particularly want to have a good safety culture. Uh, these are some things that I've heard in the past from students in the uh, undergrad chemical engineering labs. Do we have to follow the standards, the manuals? Do we really have to shut down this fire alarm? We're pretty sure it's just a false alarm. Do we have to wear PPE? Do we have to wear our glasses? Or not even asking, but just not wearing the safety glasses or wearing them on their head? If these questions or actions are taken, it's really an indication of poor safety culture. And in the current pandemic, safety is very, very important. So, in this presentation, I want to just go over a couple definitions for safety. Safety is really a broad word that's not well defined, and really it's just how to prevent or avoid accidents. Um, Near miss is a subject or a topic that you'll hear a lot about. That is something unplanned happens, and no one gets hurt. Nothing is damaged. Everything's running normal. Um, One of the best uh, things that I hear about as a near miss are slipping on ice. So you're walking into Dow, you hit a patch of ice, you slip, you do not fall, you don't break anything, you don't sprain anything, uh, and you keep going. That's a near miss. These are important learning tools. In that case, what did we learn? We need to put down salt, or the university needs to put down salt. Um, in the labs, we use near misses both to educate yourselves, the students, but also as a way to improve the labs to try and get so these near misses don't happen. An incident or an accident or something that happens and either somebody gets hurt, something undesirable happens, there's losses of equipment or work time, the damage to the environment. Obviously, we don't want these to happen. And as we'll see, we have had incidents happen in the 460 lab, but they are infrequent. And process safety is the framework for managing the systems and handling of hazardous substances. And a lot of this has to do with planning and preparation and how we run things. Process safety is typically seen as a focus of industry because a lot of the industry accidents that we hear about are lower frequency and have higher consequences. Things get, taken off site, chemicals go into wastewater and get taken off site, or there's an explosion or somebody dies. Um, Now, not to say that industry doesn't have personal safety issues. People slip, trip, and fall. Things that are lower consequence but have a higher frequency. But usually, when in industry, you hear more about process safety because you want to protect, especially those people who aren't involved with the plant, people who are off-site, people who are public. Um, why do we cover this in 460? One, we want to be safe in the labs, yes, but also it's a good training for you as students because safety cultures very important in many, many industries. Not to say that there aren't industries and companies who don't take it as seriously, but there has been a big push to educate not only students but faculty by companies, some of them on this list, uh, to talk about safety culture and process safety and how to improve the education before the students come to industry. Um, One of my recent examples, I talked with uh, a 2017 alum, Julia, and she works at General Mills, and they have many things that she has to deal with for safety on a day-to-day or week-to-week process. They have the safety trainings, much like what you did in 360. They have safety committees. Our Chemie department has a safety committee as well as the college and the university. Near miss reporting, again, as I talked earlier, it's important to catch things that could have happened poorly but didn't, so that you can ensure that those don't happen ever in the future. Um, they have short stories or short communications about safety at the beginning of every meeting. Sorry, um, and that's just a good reminder. And then, of course, they're in the food industry, so they have a lot of regulations and requirements for manufacturing within their plants to ensure that not only their people are safe, but also the foods that are leaving and going to consumers are safe. So, I've talked about this in previous presentations with the 360 class, and you may have been part of one of those. Really, hazard identification and hazard evaluation are a big part of what we can easily do in the lab. So, what hazards are there in the labs? What can go wrong? There's multiple different ways to do this. We can look at historical, what has gone wrong. We can also look at thought ideas of looking at, say, the reactor and what would happen if we went to a higher temperature than was recommended. Um, Outside of those, we can start talking about risk. Um, what are the consequences? How likely is it to happen? Um, how do we control those risks? And I think one of the big things is the risk tolerable? There is much discussion about inherently safe designs. And from everything I've been in safety trainings, it's really more inherently safer designs. There's always some level of risk. In the 460 lab, unlike in the 360 lab, we have a number of chemicals, other hazards. Um, we have a lot of chemicals that are used in the lipid extraction, hexane isopropanol. We have chemicals that are used in the reactor sample prep. And a lot of times, this is what we think about for hazards because it's easy to think about these. We have SDS that we can refer to for what is the hazard level on these. But we really don't want to forget about some other hazards that are in the labs. High temperatures, our reboiler, for instance, on the distillation is hot. And the samples that you take out of the reboiler is hot. Noise, the pod centrifuge contactor is relatively noisy, although it is below the level of needing hearing protection. Biohazardous materials, equipment breaking, which we'll talk about in a second. And of course, right now, we can't talk about hazards and risk without talking about COVID-19. For equipment damage and equipment explosions, we have, in the past 4 years, I believe, we had a centrifuge that was destroyed within the 460 lab. The students chose the wrong speed for the glass tubes that they used. The tubes broke, they damaged the plastic rotor, became unbalanced, and the centrifugal force ripped the rotor apart. Luckily, the lid stayed closed, glass was contained, nobody was hurt. But as you can see from the image, basically it was a complete loss of that centrifuge. But what did we learn? Again, no injuries, complete loss of the equipment. We learned that in the manual there was some discussion of it, probably not much. But we really needed to talk about the different types of tubes and what speeds they can go to, since there's no way to on that centrifuge to lock out a max speed. So there was signage created on those specific centrifuges that have the type of tubes that can be used, what their speeds are, and reminder to balance the centrifuge, because if you do not balance the centrifuge, that can also create hazard and damage the equipment. And training, we also have implemented it within this lecture. So we talk about something like a centrifuge exploding, and we really want to talk about the risk involved with any accident or theoretical accident that could happen. And risk, as I kind of alluded to earlier slide, is the likelihood plus or multiplied, in this case, by the consequence. So what's the consequence of it happening, and how often will it happen? If something has a high consequence and is very likely to happen, that's something we really need to improve upon. If something might happen but not happen very often, and it has a medium level of consequence, maybe that's acceptable. In industry, there is not only a level there of safety that can be talked about, but also what do we have to do to reduce and improve that risk? Sometimes it's just not feasible to do. So, as I said, we've had issues and we've had incidences in the undergrad labs, but not a ton. One of the things that I like to do is look at some of the historical incidents that have happened. So we have 9 incidences here, 3 near misses, 3 property damage, and 3 minor incidents. If you look at these, there are, for most of them, very similar causes. And those are careless lab practices. Yes, some of them might be because the SOP is not great or not written. Some of it could be bad equipment, but the majority of it is lab practices. And while we want everyone to pay attention and to understand exactly what they're doing, people make mistakes, and that's okay. This is data that's from the nuclear industry, so these numbers might be a little bit more conservative than they would be in other industries. But I think the big thing to look at this is if you look at the level of training, the level of stress, the level of fatigue, all of those have certain impacts on how often you make mistakes. So we'd really like for in the labs, I mean, we understand you're senior chemical engineers at University of Michigan, so there's a certain level of stress and a certain level of strain and exhaustion. But we'd like you to be as aware and ready to be in the lab as possible, so that you can make the least amount of mistakes and be as safe as you can in labs. So that being said, I want to talk about risk reduction. And I know things on everybody's mind and on everybody's tongue is COVID-19. And people are tired of hearing about it to some degree. And people are worried about being in the labs and in person. But I want to talk a little bit about what we did to make sure this is the safest as possible as we can and minimize that risk. The first part is we've reduced the density in the labs, and I know this is something we've talked about before. The lab densities are going to be 2/3 of what they would be normally. So instead of 3 teammates there at a time, we're going to have 2. We could have reduced this further to 1 teammate, but the impact of safety on the experiments and students with the experiments, and also the workload and stress, we thought that the additional person is very beneficial to ensure a safe and well done experiment. We've moved a lot of the some of the equipment into their own defined areas, so students don't have to move between groups and move into other areas of other groups to use equipment. There are still some pieces of shared equipment, such as the GC, the gas chromatograph, that's used by the reactor and the photobioreactor. But that was a decision based on cost. We don't have the budget to buy another gas chromatograph. They are very expensive. And so we are going to rely on social distancing and sanitizing shared spaces to minimize that risk. We've also made a lot of the areas that the students, or that you all are using in the labs, larger. We've moved things around, spread things out so that you can have social distancing between your teammates. Now, you may have to work within 6 feet for a little bit, but there's enough area there that when you don't have to do that, you can spread out. Now, what do you need to do to work safely in the labs? So before coming to the labs, and every semester I ask and say this, but please review all of the information for your experiment before coming into the lab. Read the manuals. We now have videos for video demos for the experiments. Any other videos? There should be videos and presentations on lab skills, on how to use pipetters. If you do not know, they're a major part, micropipetters are a major part of the labs. Review the SDS for the chemicals. And just look at other safety issues that you might think about in the labs. In the labs, first of all, stay home if you're sick. We have remote options and remote assignments for within the 460 lab. So if you're sick, please stay home. When you're in the lab, follow, and we hope you will help politely enforce the procedures within the labs and the safety rules. So if, for instance, I walk into the labs and I am not wearing my face shield or face mask, please point it out to me and I will get one. But be polite. And the same goes for you and your other lab mates. We all want to be safe. We all want to be healthy. Wear your PPE. So in pre-COVID times, our lab, the 460 lab, requires long pants, closed-toed shoes, lab coats, safety glasses, and gloves when you are working with chemicals. In addition to that, to be on the university campus at all, you need to wear face masks. And the college has provided face shields for all instructional labs to use. So we're going to do that to minimize, again, the risk of transmission. Also within the lab, and this is not COVID related, please properly dispose of any waste. This is something that, again, we rely on you to do as students and as experimenters in the lab. We're there to help, but it is part of the experimentation process. So for the hazardous waste, we have these bright yellow labels that you can see on the right, and they are pre-filled out for the experiment that you are on. Don't dispose any hazardous waste down the sink. That should be a given, and the only thing that should go down the sink should be water. For disposal, we have a number of containers, buckets, jugs around the labs, and read the labels on the containers. Only things that are contaminated and those chemicals should go in there. This is a compatibility issue. If you put something in there that is not on that list, it may not be compatible and may result in an incident or accident. We want to keep hazardous waste or hazardous solid and liquid waste separately. This is a university policy. We should not be mixing solid waste and liquid waste. Solid waste being contaminated consumables, so gloves, paper towels, pipette tips. They can go in buckets that are labeled solids containing these chemicals. We've had students in the past who have opened boxes of pipette tips or opened boxes of syringes and put the empty box of syringes into the haz waste, which it was not hazardous at the time that they put it in, but now that it's in there with it, it is. And that increases the load on our hazardous waste stream, which is not insignificantly cheap to dispose of. So from a sustainability standpoint, we really want to minimize incorrectly disposed of hazardous waste. Government regulations. We need to dispose of all of our haz waste within 90 days. So we need to label these. Reactor, especially when you have your waste fill up, we're going to have you remove the bottle, cap it, get a new bottle, put a new label on it, and we need to fill in the accumulation start date. With any of these, if you're unsure of anything in the lab, not just haz waste related, please ask me or your GSI. Finally, before you leave the lab, please clean up your area. Clean the glassware, straighten up the area. As you can see in the image in the upper right, this is in the reactor fume hood. You can get a lot of solids that when you leave look clear and you think it's water, but then it dries and it becomes a solid, which can be dangerous to other people. Please sanitize surfaces at the end of the lab day. Each station has a sanitizing spray bottle and paper towels. Spray down the area, wipe it down, anything that you've used. Also, when you're using electronics, spray down the paper towel with the sanitizer and then wipe down the electronics. Finally, wash your hands before leaving the labs. We do not have hand sanitizer in the labs for the reason that washing your hands is a better way to reduce the risk of contamination, both for chemicals and for COVID-19. So wash your hands and dry them and then leave the labs. Together, we can definitely have a safe in-person semester, but it takes everybody to do their part. Thank you.